Hello everyone, welcome back. In this video, you are going to learn simple and compact statements. That is the type of statement we have in logical reasoning, as well as some of the logical operators. In the last video, I described, a logic as a study of human reasoning, and I said when you are talking about logic, then you will be talking about statement. So, and don't forget a statement can what? Can either be true or false. That is a statement that can be true or false, but not both. So, and this statement, if a statement can be true or false, then we say such a statement is a proposition. We say it is a proposition, and I made mention that when you have a proposition, then we say a proposition, all propositions are statements or sentence, but not all statements are proposition. Because you can also have some statements that are not true or false. For example, when you have a question, how old are you? Or when you have a command like sit down, etc. So now I'm going to describe the categories of what? The category of statement. But before I go, so you have to know that we use logical expressions in our day-to-day activities. In fact, when you are conversant about programming, be it Python or mathematical and every programming languages, we use all the program languages we use. In the recent year, you will see that they also use what? Logical expression. So, in essence, when we are talking about the mother form of logic, then we'll be talking about mathematical logic. So at times, this mathematical logic is also referred to as symbolic logic. Symbolic logic. What's the meaning of symbolic logic? No, as the name implies, symbolic logic means that is when you are using what? Symbol. Eh? If a symbol is given a precise meaning, and it is used to make more sense of a statement. So then we have what? A symbolic logic. And you can describe your ideas with the aid of what? With the aid of sentences or statements, like I've explained the other time. So, and when we say statement or even sentence, so to say, we have two type of sentence, even in your English language. Number one, we have simple sentence, or you say simple statement. When we say simple sentence or simple statement, so there's those statements, before you can have a sentence, it must have two qualities. Number one, you must have what? The subject. What is the subject? That is, the subject is the person. So that tells the who or what a sentence is about. So that tells the who or what a sentence is about. And the second one is predicate. I hope we all know that from our English language. When we say predicate, that is, it tells us what the subject does in the sentence. For example, if I say the dog barks at the cat. So without any equivocation, so the dog is what? Our subject, because that is who is doing something in the what? In the sentence. And what is the dog doing? So it barks at what? At the cat. This is the predicate. So an example of this type of sentence is known as simple sentence. That is when you have your subject as well as what? As the predicate, we have a simple sentence. So all you just say is simple statement. So when we now say another example is we have compound sentence. So compound sentence is a simple sentence, but it is a combination of what? Simple sentences. So that is when you have two or more simple sentences joined by conjunctions. Don't forget your conjunctions. Your conjunction are or, and, between. You understand now? So that's compound sentence. That is when you have two or more simple sentences, and those sentences are joined by what? By conjunctions. By conjunctions. And in mathematics, we call this conjunction, we call them connectives. So we call them connectives. So you are going to know more about that. So in the as the videos goes on, so we have simple. Now you know the difference between simple sentence now, that is when you have your subject and the predicate. But when you have combination of what? Sentences or statement, then you have a compound statement. So know that unlike your set where you denote, in your set, when you want to denote a set, you denote set with uppercase letter, so an object with lowercase letter. So whether you can denote your statement by what? By uppercase or even lowercase. In some textbook, they denote, statement or sentence by what? By uppercase letter, or let me say, propositions. It's also proposition. So or lowercase letter. But for the case of your WAEC or NECO or JAM, so they use uppercase letter, then I think it is advisable for us to use what? Uppercase letter too. Now we know the difference between simple and compound statement. So compound statement is just like a brother of what? Of a simple statement, because when you have two or more statements that are joined together by connectives, so and these connectives, you can have, like, just like your conjunction, you can have and, or, then we can have if then. I'm going to explain very well. Then if and only if. So they are connective. They combine two or more statements together. So all these connective, I said they are what? They are called connectives. So all these connectives, they can also be categorized as logical operators. So we still refer them as H, logical operators. That is when you say logical operators and connectives. So we are saying, the same thing. So for example, now let me tell you more about them, because we are still going to be using them. Let me just draw this very well. For example, when you have something of this nature. So if I have my logical operator, don't forget logical operators are also the same thing as connective. So let me give you their symbols. So the first logical operator I will be using is what? So we call it negation. So we call it negation. I'm going to explain very well. So and the operator is what? Is not. And it is denoted by this. So in some textbook they denote it as bar or this bar. That is when you have, perhaps when you have a statement now, P for example, then you can have what? P bar or this or bar. I hope you understand now. So these are some of the examples of what? Of negation. So another type of logical operator we have is what? Conjunction. And we call this and. I'm going to explain what they mean. It's just like for your set, we have union and intersection. Don't forget when you have union of a set, I said it's like a cup-like operator. This is A union B. This is A union B. And we have intersection, that is the cap-like. So this your cap-like, when you want to describe two sets, the intersection of two sets, that is the element in A and B. If you've not watched my video on sets, then I refer you to it. So it means we can say this and also, so it is what? It is also a logical operator, a connective we use in what? In logic, and it is like what? Cap-like. It is cap-like. We call this conjunction. We also have disjunction, which is or. I'm going to explain what each of them means very well. Just pay attention It is just like a complex like this. It looks like what? Like union of a set. That's or which we call disjunction. We also have a conditional statement. Conditional statement is what? When we say something is conditional, that is condition. So that is if. So we have if, that if you do something, then. So in some textbook we call it what? Implication too. Implication. So it is denoted by this. I'm going to explain it. So then we have if and only if. If and only if. That is an equivalent operator. So I'm going to explain what each of them means. But let me, before I take it one by one, let me re-emphasize that when you say simple statement and compound statement, the difference between two of them is that for simple statement, it's just a statement, a sentence, having just, a subject and its predicate. But when you say compound statement, that is the combination of statements that are joined together by this connective or this operator we've used together, just like your normal addition, subtraction, it's an operator. So arithmetic operator. So, but we also have logical operator. So the logical operator are those I've written here. I've written here, that is negation, conjunction, disjunction, implication. So and so on and so forth. Okay, now let us take them one by one. The first one I'm going to talk about today is what? Negation. Negation. So negation can come in two ways. You can negate one statement, that is a simple statement, then you can negate what? Two statements as well. I hope you understand now. So number one, let us do that of simple statement. Simple statement negation. Or let me say negation of simple statement. Sorry. Negation of simple statement. If you don't forget, I said negation, which is also not, is denoted by this sign. So it means when I have a statement P, then this negation, so the negation of statement P, which is denoted by this, you can have negation P. Like I've said in some textbook, they can write it as P bar. I hope you understand now. So then you can also have something of this nature, negation P. This is also a negation P. And we used to read it as what? Read as not. That is not P. So that when you make a statement, maybe the boy is beautiful. Then the negation of that is not that statement. That is the boy is not what? The boy is not beautiful. I hope you understand now. So, like I've said, that the negation of a simple statement will always be false. That is the negation of P, it can be true. So the negation of P is going to be false if what? So if P is true, and negation of P is going to be true if what? If P is equal to false. So you are going to understand what I'm trying to say. So let me give you an example now. Example. So let's say I have A. Example A. So P, if P is a statement, the boy is beautiful. The boy is beautiful. The negation of P will be what? The boy is not beautiful. You understand? Now that's one of the way you can state it. Or you can say what? It is not true to say. It is the same thing. So it is not true to say that the boy is H, the boy is beautiful. I hope you understand now. Or another thing you can say is what? It is false. It is false to say that the boy is what? The boy is beautiful. So that's negation. You have to be very careful when using negation. For example, now look at that statement P, that is, the boy is beautiful. Don't say the negation is what? The boy is ugly. You understand now? Because we have different adjectives you can use to qualify boy. So then it is better to say it is not. So for example, now if I have another example, maybe I have statement Q, and the statement Q now is what? 1 plus 2 is less than 2. It's a proposition. In fact, it is what? It is a true. It is true because 1 plus 2, sorry, let me write 5 here. 1 plus 2, because this statement is false and I want to use true statement so that you can understand. So 1 plus 2 is less than 5. You can see 3 is less than 5. So if you want to find negation of this, that is negation, don't forget you can write it this way. It's going to be what? So 1 plus 2 is not less than 5. Or you can say it is false, and to means what? 1 plus 2 is less than 5. That is for simple expression, or sorry, simple statement. So if you want to take this negation of simple statement, once you have a statement, just negate it by putting not. Don't forget the first example I gave, the boy is beautiful. And the negation of that will not be what? The boy is not beautiful, or it is not true that the boy is what? Is beautiful, or it is false to say that the boy is beautiful, but you must not say the boy is ugly. The boy is ugly is not the negation of what? The boy is beautiful. I hope you understand now. So, see the second one now, let us now move to negation of compound statement. Don't forget I told you compound statement is what? Is when you have two or more simple statements that are what? Joined together by conjunction or connective or logical operator. Just like when you have two numbers now, you can join these two numbers together by addition. Addition is an arithmetic operation. Likewise, you can join two statements together using your logical operators. So I gave you some of them. One of them, which is not, I'm currently using now, that is the negation. So negation can also be applied to compound statement. I hope you understand now. And the negation, let's say I have two, suppose we have two statements. We know when we are talking about negation of, when we are talking about compound statement, so then we'll be talking about two or more statements. Let's say we have P and Q. So then the negation of P and Q, negation of P, this is negation of P and Q. I hope you understand now. So is what? Is equal to not P or not Q. So I'm going to explain that. What that is saying is that is the negation of P and Q is what? Not P or what? Or not Q. So we call this what? De Morgan's theorem. So we have De Morgan's theorem of set as well. So De Morgan's theorem is also applicable to, a logic. So conversely, you can say what? So that is when you have the negation of P or Q, it's also the same thing as what? Negation of P and what? And negation of Q. I'm going to explain that. So for example, now let me give you an example to back it up. Example, let's say I have P equals to what? 8 plus 2. 8 plus 2 is equal to 10. It's a statement. And let's say I have my Q, that is 0 is less than 2. So it is also a statement. Then the negation is what? The negation, the negation, when I say the negation of P or what? Or negation of Q, what's that going to give you? So that's going to give you what? You have something of this nature. What is negation of P? That is 8 plus 2 not equal to 10, right? Or 0 not less than what? So not less than 2, or 0 not less than 2. I hope you understand now. So, or 0 not less than 2. Or a later, another way you can say is that, so that is the negation of P, or what? Or negation of Q. When we get to De Morgan's theorem, I'm going to explain very clearly. So another thing we'll be covering is what we call conjunction. That's another operator, conjunction. I said conjunction is what? We call it and, right? So, and it is denoted by this. So it is denoted by this. So what I wrote here, you can rewrite it as what? This also, before I go, this same thing as negation of P and Q. So don't be confused. So when we now say conjunction, don't forget conjunction is a connective, and before you use connective, so you must have two or more statements. When we now say a conjunction, that is a compound statement. I mean a conjunction of a compound statement let's say of maybe two propositions. Yeah. So joined by what? By the word we use and, or you use this symbol above. So we denote it what? It is denoted by what? So by cap, just like which look like that of intersection. It is denoted by this. I hope you understand now. So it is denoted by that. So when you have this kind of symbol and, we call it what? A conjunction. So for example now, example, when you have an example, so the sun is shining, the sun is shining, and Q, Gafari needs an umbrella. So the sun is shining, Gafari needs an umbrella. You can see that P is a statement, Q is also a statement. So from the two statements, that is P and Q, so we can have a compound statement of P and Q. Then we can have P and Q. What will now be of P and Q? So statement P and Q will now be what? So the sun is shining, the sun is shining, and what? And Gafari needs an umbrella. And Gafari needs an umbrella. So symbolically, like I've said, you can just say this what? P and Q. I hope you understand now. So that represents conjunction. So that represents conjunction. So if that is clear, let us move to disjunction. So disjunction is more or less your union. It's more or less union of a set. Disjunction. Disjunction, or we call it or. It's disjunction operator or operator. So disjunction of two proposition denoted by P or Q. This is P or Q. I hope you understand now. It's a compound statement of two propositions joined by what? Joined by or. Joined by the word or. And it is denoted by this, like I've said. So for example now, example, don't worry, you will get the explanation very clearly in the next video. Mariam is eating rice. Mariam is eating rice. So if this is statement P, for example, Q Abdullah is eating fish. So when we want to use disjunction, that is, if you now, P is a statement, a simple statement for that matter, Q is also a simple statement. So when we now want to combine the two statements together, you will using the word or. Then P or Q now will now be what? Mariam is eating rice, or what? Abdullah is eating fish. Sorry, I want to highlight fish here. So I want to write fish here. I'm going to tell you what they all mean theoretically, or Abdullah is eating fish. I hope you understand now. Or Abdullah is eating fish. So when you join them together using what? Using the connective or, then we say we have what? Disjunction. We have a disjunction. So then you have to note that when we have this word or, this or, you understand now? So can be used in two ways. We have inclusive way or exclusive way. When we say inclusive way, let me remind you, when we were defining what? So the union of two sets, I said union of sets A and B is what? Is defined as element in A or element in B or element in both A and what? And B. So when you are defining union like this, then we what? We call this an inclusive definition. I hope you understand now. So, but an exclusive definition is one that does not take into account both of them. So it's just A or B. So in essence, so for an inclusive proposition or inclusive or disjunction, then I'm going to have Mariam is eating rice, or Abdullah is eating fish. I hope you understand now. So, or Mariam is eating rice and Abdullah is eating fish. I hope you understand now. So that is that. That is that. That is for inclusive sense. That is for inclusive sense. When you have P, when you have P or Q, then you'll be talking about what? Eh? P or Q, or both P and Q. That's for inclusive definition of disjunction. So then we have exclusive. What will now be the exclusive? That is when you don't include this. So exclusive definition, exclusive. Then we have what? P or Q only. That is P or Q. So without adding what? Without but not both. Without taking into account both. So I hope you understand now. So, but in your mathematics, we use our inclusive definition. So we use it most of the time. So in essence, when I'm talking about P or Q or P disjunction Q, then you have to know that we are talking about P or Q or both P and what? Or both P and Q. So if that is cleared, another type of logical operators we'll be using is known as conditional statement. Conditional statement, as the name implies. You understand now? That is, you are talking about condition, that the condition of a statement, that one of the statements happens. So a conditional statement is a statement of the form, that is, if a statement, then another statement. So maybe, for example, if I have two statements P and Q, so then conditional statement is like if P, then Q. I hope you understand that. That is, if a statement, then another statement. So they are proposition. So that statement means, that is, P implies Q. I hope you understand that. That is, the first statement implies the second statement. And many statements we are going to be using, or in general, many statements we use in mathematics are of this form. So, and when we say this first part here, the first part after if, we call it what? Antecedent. What did I call it? An antecedent. And the second statement, so is what? It's called consequent. So it's called a consequent. So when we say anti means before, that is a statement that comes before. So whereas the consequent means the one that comes immediately after them. I hope you understand now. So and like I've said, it is denoted by P implies Q. Don't forget your P is what? Antecedent, and your Q is consequent. So that is if P then Q. So but in mathematics we have different expressions for what? For this conditional statement, it can mean P implies Q. It's also the same thing as P provided Q. You can call it P only if Q. Then you can say P is a what? A sufficient condition of Q. In some textbook, you can say Q is what? Is a necessary condition of P. I hope you understand now. It is just like that. It's just like that. Let me give you an example to understand what I'm trying to say. Example. So let's say if they pay my salary, if they pay my salary, then I will travel to Mecca. So if they pay my salary, then I will travel to Mecca. So you know we have two statements here. The first statement is what? If they pay my salary, I hope you understand now. Then the second one is what? So I will travel to Mecca. So the first one is an antecedent, that is, it comes before the condition. That is the condition that I'm going to travel to Mecca is what? If they pay my what? If they pay my salary. I hope you understand now. Like I've said, so the antecedent there is what? If they pay what? If they pay my salary. I hope you understand now. So and the, uh, the consequence is I will travel to what? I will travel to Mecca. So then this is going to be what? P implies Q. So that is if this first statement is P and this is what? It's also a Q. For example, another example is that, so maybe if I say the student can solve the problem only if he goes through the work. So only if he goes through the work. I hope you understand now. What will now be your antecedent? So your antecedent will be that the student can solve the problem. I hope you understand. And your consequent, that is what will happen if the student can solve the problem, then it means so he has gone through the work. He has gone through the work. So that's for conditional statement. So from here, let me quickly describe what we call a converse statement. What is converse statement? So the converse of a conditional statement, you can take converse of a conditional statement. You know a conditional statement is what? If P then Q. I hope you understand now. So then the converse of this, the converse of if P then Q is another conditional statement. So is the conditional statement is the conditional statement if Q then what? Then P. I hope you understand that. That is why I want to say conversely. So, or let me say, if you have a statement P that is P, if P then Q, then conversely, you understand now? Then conversely, what you are saying is what? So conversely, you are saying if Q, then P. So you are saying if P, conversely, you are saying if Q, then P. You are saying if P, if Q, then P. So then if that is cleared and you understand that, let me give you an example. So for example, if I give you two statements now, and both of them, I mean, they are connected with what? Implication sign. For example, if 9 is less than 19, if 9 is less than 19, you know, 9 is less than 19 is what? It's an antecedent. It's an antecedent. Then 8 is less than 5 plus 6. So find the converse. If you are asked to find the converse of this statement, find the converse. Find the converse. What will be the converse of this statement? If 9 is less than 19, then 9. So it means the converse of this statement will be what? If 8 is less than 5 plus 6, then 9 is less than what? 9 is less than 19. That's just it. You just change, you interact the antecedent with what? With the consequent. So that is if 8 is less than 5 plus 6, then 9 is less than 19. Can you see we just change the antecedent and with the what? With the consequent. Okay, can you quickly say this? Let's say if two triangles are equiangular, then their corresponding sides are proportional. So what will be the converse statement? So then conversely, we can say if two triangles have their corresponding sides to be proportional, then they are what? They are equal angular. So they are equal angular. So another thing I want you to note is we can have an inverse statement. So before I define what we call what? Eh? So the equivalent statement. So when I say the inverse statement, this inverse statement as well as the converse statement, so they are only applicable to your what? To your conditional statement. So when we say inverse statement, so the inverse statement of this conditional statement of if P then Q. So then the inverse statement is what? If not P, then not Q. If that is inversely. You have to know the difference between what? Inverse and converse. So that is if not P, then not Q. For the converse, it means you have to interact the antecedent and what? And consequent. That is, if you want to take the converse of if P then Q, then conversely you say if Q then P. But when you want to take the inverse of that statement, it will be what? If not P, then not Q. I hope you understand now. So in essence, if I have P implies Q, I hope you understand now. Then the inverse will be what? Eh? Not P implies not Q. That's emphasis. That is the negation of the statement P implies what? The negation of the statement Q. So implies the negation of the statement Q. I hope you understand now. I hope you understand now. So, and lastly, or before I go, let me give you an example here. So, example, example. So write the converse and the inverse of the following. Number one, M implies N. Number two, A implies B. I hope you understand now. So what will be the converse of the first one here? So conversely, so don't forget conversely means you have to interact the what? The antecedent as well as the what? As well as the consequence. So this converse is what? N implies M. I hope you understand now. So but converse for this one be what? The negation of B implies A. That's the converse. So that is the negation of P implies A. So that is conversely N implies M. Okay, what of inverse? What of inverse of this? Inverse will now be what? Not M implies what? Not N. It is as simple as that. Okay, now can you find the converse of this guy? A implies not B. That is, not B implies A. I hope you understand now. So, and what will now be the inverse? Not A implies not B. And the negation of something is that thing. I hope you understand that. The negation of A is A. It means this one will be what? Negation of A implies B. So negation of B is what is B. And that's that. So that's that. And lastly, let me cover what we call what biconditional. You know, we have conditional, biconditional. That's when you have two conditions. You know, for the biconditional now, we have like if then. You understand now? So then it means for biconditional, we are going to have if then if. So that is the statement. Okay, we have biconditional, which is also the same thing as equivalence. We call it equivalence of what? Of proposition. Of propositions. Okay, now, so the statement P equivalent to Q, we call this as an equivalent, is known as what? Is known as biconditional statement, or you say by implication of P and Q. So that is what he's saying is that P implies Q, then conversely. Then it and what? And conversely. What is the conversely? That is Q also implies P. So this means an implication which is read in two ways. So and we usually join them together, I mean using if and only if. So that is now for a conditional statement you have if then, but for biconditional statement you have if and only if. So it means if I say if and only if P, P if and only if Q, then I'm saying what? Maybe if I say P if and only if, because we denote if and only if by this Q, then what I'm trying to say is that P implies Q and then the converse, Q implies P. We use all this when we are proving what? Mathematical theory, some mathematical theorems. I hope you understand now. So, and it is sometimes referred as equivalence of P and Q. So we denoted them by what? In fact, you can write this as this. You know, I describe an equivalent what? An equivalent set for you as well. Don't forget an equivalent set, that is when the cardinality of P is also the same thing as what? As cardinality of what? As the cardinality of Q. I hope you understand now. So if you don't forget, so let me quickly review that them for you all. That is when you have your logical statement. So your logical statement. So we have their symbols. So the first one is what? So we have the negation. So and this negation we call it not. So you have your conjunction. Sorry, we have conjunction, which is also the same thing as and. So or and, which is denoted by this. We have disjunction. Disjunction is denoted by or, which is this. So then you have your what? Conditional statement. So which is the same thing as implication. I hope you understand now. We call it conditional. or implication, we use this symbol. So we have an equivalence or biconditional So which is same thing as what? If and only if. So which is same thing as if and only if. This you can say it is what? If then, sorry, if then, and this is what? If and only if. So please note this very well, and don't forget I told you can find the converse as well as what? As the inverse of what? Of an implication or a conditional statement. We are going to use all these in example in the subsequent video. So if you enjoyed this video, please don't forget to like, share, and subscribe. And if you are serious about learning mathematics from scratch, then you have to subscribe to my channel and click on the bell button so that you get notified anytime I post my video. See you in the next video. Thank you.